Okay, let's try this problem. Here, we've mixed 5 grams of potassium nitrate into 75 grams of water. This causes the temperature to decrease from 24 degrees to 19.6 degrees. And we're supposed to calculate the enthalpy of this dissolving process in units of kilojoules per mole of potassium nitrate. So what we've been given in this problem is a mixture of two things. Now, this was not a situation where hot meets cold. Instead, we have a situation where two things have been mixed and either a reaction or a dissolving process has occurred. We're dissolving. Okay, so the way we start these problems is we say heat lost by the reaction. Now, again, technically this isn't a reaction. We are rearranging bonds. We are going ahead and breaking apart the ionic bonds between our potassium nitrate crystal structure. We're separating water molecules and then reestablishing new intermolecular interactions during the dissolving process. I'm just going to call it a reaction here though. Heat that's lost by the reaction is negative heat that's gained, and the gain in this case, everything in the cup gains that energy. So we're going to say heat gained by the solution. Now, what we're looking for is the heat gained or lost by a reaction. That is the variable we want to solve. We're going to calculate this in joules, and then we just need to change it to kilojoules and divide by the moles of potassium nitrate that we used. So leave this variable alone. Q reaction equals negative. Now the heat gained by the solution. Well, in this case, the solution actually lost heat. The temperature decreased, but that's okay. We'll say gained. But how do we do a temperature change of the solution? Well, we're going to use an MCAT of the solution, where M is the total mass of the solution, C is the specific heat capacity of the solution, and T is the temperature change. Let's go ahead and plug in our values. Q reaction equals negative. Now, the total mass, we've gone ahead and mixed 5 grams of potassium nitrate with 75 grams of water. That gives us a total mass of 80 grams. We've got 80.0 grams times a specific heat capacity. They want us to use water's specific heat capacity because this is mostly water. So we're going to use 4.18 joules per gram degrees C, and then our temperature change. We're going to take the final temperature minus the initial temperature. So final temperature is 19.60 degrees C minus original temperature, which is a 24.00 degrees C. Celsius cancels out, grams cancel out. Now, this temperature change is a negative 4.4 degrees C. When we take a negative temperature change times a negative in the front, we get heat of reaction is a positive value. That positive value turns out to be 1,470 joules. Now let's analyze that positive value. The positive implies an endothermic dissolving process. That means when those bonds all begin to rearrange, they absorb energy from the surroundings. What's the surroundings? The water. The water is the surroundings. That's where the temperature probe, the thermometer is sitting in. So if the water starts to lose energy to those molecules that are being rearranged, well, if they lose energy, the temperature goes down. That makes sense. We have an endothermic dissolving process here. So we now have the heat of this process, this reaction, in joules. They want it in kilojoules per mole of potassium nitrate. Let's go ahead and change that to kilojoules right away. I'm going to go ahead, get rid of joules. There are 1,000 joules in 1 kilojoule. That leaves us with a positive 1.47 kilojoules. Now we need to take those kilojoules and divide them by moles, kilojoules per mole. So let's go ahead and get our moles of the potassium nitrate. We had 5.00 grams of the KNO3. In order to get our moles, we just need to divide by the molar mass. 1 mole of potassium nitrate is 101.1 grams. That leaves us with 0.0495 moles of KNO3. Okay, last step. To find the enthalpy change for this dissolving process, we're going to take the heat and we're going to divide it by the moles. So the heat in kilojoules, positive 1.47 kilojoules. Our moles, 0.0495 moles. If you divide those two values, you get an endothermic enthalpy change of 29.8 kilojoules per mole of potassium nitrate. I hope that helps. Take care.